In this video, we will introduce linear algebra as well as Gaussian elimination. In particular, our introduction will start with one application, a common application, which is the simultaneous solution to a set of linear equations involving several unknowns. We will talk about what it is to be a linear equation as well as a general linear system. We will look at a theorem which will give us elementary row operations that will allow us to solve general linear systems. And finally, Gaussian elimination, which uses these elementary row operations. Gaussian elimination will then give us a very systematic and proficient way of solving these systems. Since this is the first video of a series of videos for linear algebra, I do want to introduce the videos by saying all my videos will start with this kind of summary slide. The summary slide will have all the points that are important points of the video. I like to try to get everything on a single slide because one, I think it's nice to have this everything in one spot so you can have this nice big overview. Two, I feel like it makes everything more manageable to be able to see everything at once. And then last, I think it's a very good start to a cheat sheet or set of notes that you can use for quick reference. The second comment I have for you is about the linear algebra class itself, and that is the first 3 or 4 subsections of chapter 1 deal with a very straightforward, simple example of an application of linear algebra, which is the simultaneous solution to a set of linear equations involving several unknowns. So this topic itself is something you have probably covered in middle school, and many college classes, because it's sort of middle school kind of material, will skip this material and expect you to cover it on your own. And that is one choice. I have made the choice, and many textbooks and classes do this, go over this material again for several reasons, one of which is there are some very fine details, or there are some details that you may not recall or may not have had in middle school, but they're very important. So it's important when you go through these things, a lot of things will be very easy for you, but pay attention for the things that you may not have known. It's important that you pick them up now. The second thing is if you have to do Gaussian elimination by hand, it's important you become proficient at this. So you should become speedy and proficient at doing the calculations and the ideas. You should be able to pick up all the ideas in this video. And again, be careful because the first three or four videos or subsections of your chapter are likely to be very easy. They're like middle school kind of material. However, linear algebra will pick up. It will get hard and it will need your time and attention. As I mentioned, we will start by finding simultaneous solutions to a set of linear equations involving several unknowns. First, we'll define what it is to be linear. An equation is linear when each term, and again, a term is, when you add two things, the things that you're adding are called terms. So the things in between the plus and minus signs. So an equation is linear when each term has degree 1 in each of its variables. So for example, here we have two variables, x1 and x2, and its degree is 1. And so this equation is linear. Here we have an equation with this term here with x1 times x2. So this term, since it has two variables multiplied, its degree is 2. And this is x4. This variable's degree is 1, so this term is okay. However, this term makes this whole equation nonlinear because of the second degree term x1, x2. Here we have x to the minus 1. Well, that also is not degree 1. And then the sine x2, that totally makes it not linear. So both of these terms makes this equation nonlinear. And x1 to the 1/2, that's also not degree 1. So, and this term is degree 1, but this x to the 1/2, x1 to the 1/2 makes it nonlinear. General linear systems, they are an m by n system of linear equations, and that m is the m linear equations, n is the number of knowns. So here we have an example of a 2 by 3 system of equations. That's 2 equations, 3 unknowns. So 2 equations, 3 unknowns, x1, x2, x3. And we can verify it has at least one solution, x1 equals 1, x2 equals 0, and x3 equals 1 by plugging in these variables into both equations and seeing that this set of this solution, this x1, x2, x3 solution, will solve both equations. To solve these systems of equations, you learned how to do this probably in middle school. You used these different rules. So we have this theorem: if any one of the following elementary operations, these three, is applied to a system of linear equations, the resulting system is equivalent. And by equivalent, we mean the resulting system has the same set of solutions as the original set of equations. So the different elementary operations you can do is you can interchange the order of two equations, multiply an equation by a non-zero scalar, or add a constant multiple of one equation to another. As an example, let's look at this here. Our 2x1 minus x2 minus 3x3 is equal to -1, with our equation minus 2x1 plus 2x2 plus 5x equals 3. First, we can interchange the two equations. So I'm sure you will agree I can write this equation on top, my minus 2x1 plus 2x2 plus 5x3 equals 3, and write this equation here on the bottom, 2x1 minus x2 minus 3x2 equals, minus 3x3 equals -1. And you will agree these two sets of equations, systems of equations, will have the same solution. Again, just interchanging the two rows or two equations. Multiply an equation by a non-zero scalar. So I can multiply, for example, this top equation by 2, and I would get 4x1 minus 2x2 minus 6x3 is equal to -2. Since this equation is equivalent to this equation, then we assume that the system of equations, the two systems of equations, will also have the same solutions. Last, we could add a constant multiple of one equation to another. So for example, we can multiply 2 times the first equation, that's E1. 2 times this first equation, add it to E2. So first I have my E1 equation here, 2x1 minus x2 minus 3x3 equals -1. But now I'm going to replace the second equation with 2 times the first equation plus E2. So 2 times this will give me 4x1. When I add it here, I'm left with 2x1. Multiplying by 2 again, so I have minus 2x2 plus 2x2 will give me 0x2. Here I'm multiplying by 2, I get my minus 6x3 plus 5x3 gives me an x3, and then finally multiplying by 2, minus 2 plus 3 will give me 1. And from middle school algebra, you know that this system of equations will have the same solution as this system of equations. Gaussian elimination gives us a systematic way of solving an m by n system of equations using these elementary row operations. So the first step, if necessary, we want to interchange the first equation, the first row, with another so that x1 appears in the first equation. Step 2, eliminate x1 from every equation but the first by adding the appropriate multiple of the first equation. And step 3, temporarily ignoring the first equation, you look at the remaining equations as a system of m-1 equations in the unknowns x2 to xn, and repeat the procedure of the system until you have triangular form. So we'll do an example. Here is a system of equations. It's a 3 by 3 system because there are 3 equations and 3 unknowns. So the first thing we do is we want to interchange the first equation with another so that x1 appears in the first equation. Well, we don't need to do that because x1 here appears in the first equation. Now we want to eliminate x1 from every equation but the first by adding the appropriate multiple of the first equation. So here, to add this and get rid of the x1 term, we need to multiply by -2 on the top and then add. So here, our second equation is E2 minus 2E1. So when we do the -2, we get 0, x1. The -2, we have 4x2 now. Added to this x2, we get 5x2. And now, again, a -2x3 added to the x3 gives us a 3x3. And a -2 here gives us a -4 plus 1 gives me -3. On the bottom, to get rid of the x1 term, we have to multiply the first equation by 3 and then add to this third equation. So that's multiply the first equation by 3 and add to the third equation. So that gets rid of the x1 term. Our x2 multiplying by 3 gives us -6 plus 1 is -5x2. Again, multiply by 3, that gives us 3x 3 minus 2, that leaves us with 1 more x3, multiplied by 3, that gives us 6 minus 5, that gives us 1. So this is our second step, or kind of next step. Now we're going to ignore the first equation, and we're going to treat this as a 2 by 2 system of equations now with two variables, x2 and x3, and we're going to repeat. So I have my x2 in the first equation. Again, we're ignoring this. And now I want to get rid of x2 from all the other equations. I can do that just by adding e2 to e3. So adding these two together, I get 0x2. Adding these two together, I get minus 2x3. Adding these two together, I get minus 2. So this is triangular form. In other words, each row, we get rid of one more term until we kind of have this triangle. And then we can back solve. So x3 is equal to 1, and then plugging 1 into here, we can get x2 is equal to 0, and x1 is equal to 1. So it's important for you to know how to solve a system of equations efficiently, which is what this Gaussian elimination is. But a lot of colleges will consider this kind of middle school algebra kind of work, and so they will allow you to use matrix solvers to do these calculations for you, sort of like how they don't sometimes let you use a calculator to do addition. So your school may let you bypass this, but either way, especially if they don't allow you matrix solvers, you do want to be able to do this efficiently. And if you are not allowed to use a matrix solver and you have to do this by hand, I highly recommend you do these notations so you know how to get from one step to the next. That way, if you have an error, when you come to the solution and you plug your solution back into the equations to verify if it works, if something goes wrong, you can go back and quickly trace what you did. And again, the notation then is the first equation is the equation you're replacing. So here in this first step, I'm replacing the second equation, row 2, with e2 minus 2e1. So that's how we get the second equation here. It's e2, this e2, minus 2e1. And then the other substitution I'm going to do is I'm substituting equation 3 with e3 plus 3e1. So this is a nice notation for you to get used to, not just seeing, but when you do your when you do this by hand, it's a good thing for you to do, a good habit. Two more examples because it's important for you to know, especially this one, when systems don't have solutions. So here we have a system of equations, again, 3 equations, 3 unknowns. And the first step, interchange the first equation with another, so x1 appears in the first equation. So the first thing we're going to do is interchange, which I have with this back and forth arrow, e1 and e3. So here's e3, the third equation, my e2 stayed, and then my last equation is over here. My first equation is on the bottom. Now I want to remove x1 from every equation but the first. So here we don't have x1, so I only need to do that with this. So I multiply the first equation by 2, and then add these two together to get this equation here, right? When I multiply by 2, add these, the x1 goes away, multiply by 2, add these, the x2 goes away, multiply by 2, I get 3x3, multiply by 2, I get 6. So this is my next iteration. Now we're going to ignore the first equation and pretend like we have a 2 by 2. The first step is to change so that x2 appears in the first equation. So we just change the rows. So I have this notation, I swap them. So I have x1 I just copy over. I swap these two equations. And then you can see I already have triangular form. The bottom equation only has one variable, the next equation has 2, and the last equation has 3. Or you can think of it, each time you go down, you eliminate one variable. It's in triangular form, and then you can solve back, and you get x3 equals 2, x2 equals 1/2, and x1 equals minus 1/2. This next example is an example of a system of equations that has no solution, so it's important that you know what that looks like. So we start with these 3 equations, 3 unknowns. Our x1 is in our first equation, so we're good there. Now we need to get rid of x1 in equation 2 and equation 3. So to get rid of x1 in equation 2, we just need to add x1 to x2. So we've done that here. This zeroes this out. This gives us our 2x2, this gives our x3, adding these two we get 2. To eliminate the x1 from the third equation, we're going to multiply the top equation by -2, so minus 2e1, and add it to e3. So minus 2, we get rid of that. Minus 2 here, we'll get a positive 4x squared. Minus 2 here, we'll add it to the 4x3, we get 2x3. Minus 2 here will give us minus 6, plus 12 gives us 6. So again, do notice how I'm doing these notations. This will help you if you're having to do a lot of this. Our next step then is to look at x2. We want to eliminate x2 from the bottom equation. So we're going to multiply the second line with minus 2 and add it to the third equation. So we eliminate our x2, minus 2 here, we eliminate our x3, minus 2 here will give us minus 4 plus 6 gives us 2. So what we're left with on the bottom equation is 0x2 plus 0x3 equals 2, and obviously there's no x1 and there's no x2 and x3 that can satisfy this equation. So this system of equation has no solution, and we say it is inconsistent. What we talked about in this video is we talked about linear algebra and its goal of finding simultaneous solutions to a set of linear equations involving several unknowns. We defined linear. That means each term has degree 1. So here, this one term, terms are separated by addition signs. This one term has two variables multiplied together, so this term's degree is 2, so it's not linear. We talked about general linear systems. That's again, if it's an m by n system, that means we have m linear equations with n unknowns, and we had an example. We talked about when we have linear equations, the elementary operations that we can do without changing the solutions sets of the system of equations. So we can interchange two equations. We can just move them in order. We can multiply an equation by a non-zero scalar. So again, if I multiply this by 2, or maybe this by 3, I still have the same system of equations, same solutions. We can add a constant multiple of one equation to another. So I can add 1 times this equation plus this equation, and my system of equations will have the same solutions. And then we did Gaussian elimination, which was an orderly, systematic way of solving these systems of equations. And many of the topics in this video are things that you learned in middle school, but we just want to make sure that you are proficient, you have this Gaussian elimination, a way of approaching these problems efficiently. And there will be another 1 or 2 videos that are sort of similar, covering basic things you've known for a long time. Actually, one of them I might skip and just say I'm sure you know how to do it. But the idea, the warning I want to give you is linear algebra really does go way beyond this stuff. So don't get lulled into thinking that this is an easy class. It is very manageable if you keep up, and especially if you make sure you remember your definitions, which we'll talk about. I'll tell you which definitions you really want to pay attention to. Anyway, that's it for this video. Thank you for watching.